The Rotor is a ride at an amusement park. All it is a big round room. They let people in, and people line up against the wall. And once everyone is in place, they begin to rotate the ride. The wall provides a normal force, which acts as the centripetal force, which holds the people in the circle, and it also provides a frictional force in the vertical direction between the wall and the person. And when that becomes sufficiently large, they drop the floor out from under your feet, and the frictional force supports your weight. If you've ever been on one of these rides, you'll see that the wall is made out of a very sticky rubber, very similar to that what you would see on a ping pong paddle, so that there is a high amount of friction for a low normal force. So here's our force diagram for the Rotor Ride. This dot here represents a person standing against the wall. The wall provides a normal force which pushes the person towards the center of the circle. The weight of the person is down, and the frictional force is what is going to hold the person up. So we're going to try to predict what is the minimum tangential velocity needed to keep the person from slipping down the wall once the floor drops out from under their feet. Again, we're going to let the positive x direction be toward the center of the circle and the y direction be straight up. We're going to apply Newton's second law to the x and the y directions. So in the x direction, I have the normal force that acts as my centripetal force, which provides my centripetal acceleration. So I come up with normal force equals mv squared over r in the x direction. In the y direction, I have the frictional force upward and the weight downward, and they add to 0 because there is no acceleration in the y direction. And I see that the frictional force is equal to the weight, and the frictional force is also mu times the normal force. So if I solve this equation in the y direction for the normal force, I get mg divided by mu. I can plug that in over here in the x direction, and you see that the m's cross off from either side. What does that mean? It means that the mass is not important. The same minimum speed will cause a light child to stick to the wall, and the same speed will also allow a big heavy person, such as a 250-pound adult, to stick to the wall at the same speed. So the m's drop out, and I solve for v. The square root of g times r over mu is the minimum tangential velocity so that a person will not slip down the wall.